Hello. If I start off by saying this is not my comfort zone, um, I I don't do this normally. Please excuse mistakes and and whatnot, because otherwise it's going to take me 100,000 attempts at recording this, and I just don't have the time. So, this video is for my A-level class to help you with simplifying Boolean expressions. Those of you watching this, you should have in your notes the laws, the common laws for to be used with simplification. Those are there in that table. Make sure you've got a copy of those nearby. You can refer to those. The tips on here, I will try to point these out as we go through and do some examples. The idea is, basically there isn't a fixed order for simplifying Boolean expressions. That's very clear when we look at the mark schemes for exam questions, because there's lots of different solutions, lots of different ways of doing it. So I'll talk you through some of them, try and highlight why they are like they are, and hopefully you'll start to pick up some patterns. I think a really good tip is to look for some easy wins. So we'll try to spot some basic identities as we go through, using De Morgan's law, but sometimes we're going to have to factor or combine terms, and we're going to need to distribute terms. That's just will help the process. Okay, so hopefully this video makes sense. If not, I'm sorry, you'll have to find someone else. Okay, so question one. Again, a few different solutions for this one, but we'll just have a look at this to start with. First things first, I want to point out that we are going to keep these together and these together as much as possible. It's really important that we sort of keep the bar will help treat this as a unit. That's why it's there. We are treating these two groups as a unit. So sometimes we'll need to apply brackets to keep those together. So I'll show you what I mean. Okie doke. Now we're actually going to start on this one with this bar here, and I'm going to get rid of that. So we're going to apply De Morgan's, and we're going to bring the B down. Because we've applied, we're breaking the bar here, we're going to change the operator to an OR, and we've got not A. Now this one would be not B, but that cancels out, so we can remove that. Now, because I've broken the bar here, I am going to put brackets to keep those together. Then we have our and, not B, and that is going to have a bar all the way across still. And the remainder of our expression remains the same. So we've applied De Morgan's first of all. Now the next bit, we are going to expand these brackets out, which seems silly because we've just put them in, but that's what we're going to do. So we're going to take our not B, and we're going to and that with the B. So we've got B and not B. And then we're going to do the same. Now this is going to be an OR. So we're then going to take our not B and not A, and we're going to bring those together. Okay, now these expressions still have a bar running all the way across, and we still have our OR A and B. Now this allows us to spot an identity, which we have here, B and not B. So B and not B is going to always be 0. So we have 0 or not A and not B. And again, we still have our bar running across the top. I'm starting to squidge those together. I apologise. And so we have a 0 or A and B. So that's just going to be the this side. We can get rid of our 0 or using that identity. So I'll try and be a bit lower here. So we've got A and B with their not, and they're not running across the top. We've got rid of this section here, and that is still ORed with A and B. So now we're ready to break the bar, and again those knots are going to cancel out, so we just have an A and B. Now this, because we've broken the bar, we're going to change that operator, so we have A or B, or A and B. Now we're going to apply the absorption law. Okay, so again, we have the A and B here, and we're going to look at, we've got A and B or B, and the absorption law, we're going to see we've got the B on each side, so it's going to absorb basically. So our answer is A or B. I didn't mean to swipe there. I didn't know, I was going to show you a different solution, which is a slightly shorter version. So this time, now I'm going to copy this across really quickly. So we've got not B and A and not B or A and B. Let's do our bar across the top there, and then bar across all the way, sorry. So this time again we're going to apply De Morgan's law, but we're going to apply it here. So we have a B, now the knots have cancelled out, we'll put the OR in here, and the two bars here get cancelled out, so we end up with not B and A. And then we still have our OR, A and B here. Now what we're going to do is we're going to identify a common factor. So we can see we've got not B and A here, and we have A and B here. So we've got our common factor, which is A, and we'll put our not B or B in our brackets, and then we still have our or B from this middle one here. So we've got A and not B or B, or B, and as you know, not B or B is going to be 1. So we have A and 1 or B, and anything ANDed with 1 is going to be whatever this is. So we have A or B. So two solutions there, two different solutions to the same problem. Question 2. This one might be familiar to you. So we're going to start with De Morgan's again. So we've got our bar, which we're going to get rid of. So we'll break our bar here. So this double knot here will be nulled. Now we're going to change the operator from an OR to an AND. We'll keep our brackets, and we have not B and C. Now that will have a bar running across the top. We can apply De Morgan's again here by breaking this bar, so we just have a B or not C, still with our A here. Now that we're going to keep within our set of brackets just like they were at the top here. I'll there. We'll fill this in here. Okay, B or not B and A. So we're going to deal with this section next, and we're going to expand the brackets. So we'll take A and B, or A and not C, still in brackets. We still have the remainder of our expression there. Now we're going to expand the brackets again. So we can see we've got our and here. Oops, don't know how I managed to erase that. So we've got our and here, so we're dealing with this part of the expression because we have B and all of the bits in these brackets. So we're going to get rid of those brackets by anding with the B. So we're going to do, first of all, we're going to do B and this side. So am I on the right one? Yep. So we're going to do B and A and B, and then we'll do the other half of that. So we'll do or B and A and not C, and we still have that ORed with A and not B. So we've got A and not B, or B and B and A and B, or B and A and not C. So we can collect some terms here. We've got, if we look at this bit in the middle, first of all, we can reduce that down. B and A and B, again, easy win. We can just say A and B. We've got B and A and not C. Am I running out of space? Maybe. Living dangerously now, getting messier. So we can see now here on this side, we can actually bring in some brackets and collect some terms because we've got A on both sides here. So we're going to look at A and not B, or A and B. So we can collect that. We have A and then brackets not B or B. So not B or B is going to be 1, A and 1 is going to be A. And then over on the other side, we still have our or. So if I bring this down to our A, we have or B and A and not C. Now again, our rules of absorption, these are together, so we have A or B and A and not C, and the rule of absorption is that that will equal A. Okay. All right, question 3. Now we've got quite a lot going on here. We've got quite a few brackets, we've got our long bars going across the top, so there's a few different places that you could start with here. I am going to start with the bar, and we're going to break the bar. So break the bar, we are going to change the operator from an or to an and we are going to have our brackets over here with not B and not C, and they are going to have a bar across the top. And then over on this side, because our bar is now going to be the same length as the one underneath. They're going to cancel each other out, so we can just bring this expression down. So we have not A or A, and A or B. Okay, now we can apply De Morgan's again because we've got another bar. So let's get rid of this bar. We have B or C, and the rest of this expression is the same. Here we go. Now, we're going to look for another easy win, and just like we've done previously, we've had the rule of absorption. So we have here A and A or B. We can use the absorption to just reduce that to an A. So we have not A or A here, and B or C over here. We know that not A or A is going to be 1, and then we have B or C over here. So 1 and B or C means that it is just going to be B or C. And that's our simplified expression. That was me trying to close. Come on.